Hi folks, this is a brief lesson on evaluating a polynomial. Now, evaluating a polynomial seems really boring, but it becomes slightly less boring when we're thinking about doing it on a computer. Now, why would you want to evaluate a polynomial on a computer? Well, if you have to do it many times over and over as part of some algorithm, doing it by hand is obviously going to get really tedious. So you want to do it on a computer, and you might think that that's an instantaneous process, like say evaluating a certain polynomial at a certain point on your computer takes 0.005 seconds. And that seems really fast. It's like, just like an eye blink or something. But what if you're solving a problem that requires this to be repeated many times? So you have millions of polynomial evaluations. Then you're talking about a significant amount of time, and you really should worry about how fast your algorithm is, because there's a big difference between it taking 2 seconds and it taking 20 minutes if you do something inefficient. So in that vein, we're going to talk about 3 different ways of evaluating a polynomial. The first way is just naive evaluation. So suppose we have this polynomial here, it's a quartic polynomial, and we want to evaluate it at the point x equals 1/2. So we just do the naive thing, like we take the number 2, and we have to multiply it by 1/2 to the 4th power, so there's 4 1/2s here, and we can count the number of multiplications necessary to calculate that. There's 1 to multiply those 2 numbers, and then a second one, and then a third one, and a fourth one. So that's 4 multiplications right there. And you can continue on with the rest of the terms in the polynomial. And then you have to worry about adding the terms together. And by the way, we're going to count subtraction as the same as addition. So there's 1, 2, 3, 4 additions. And if you add up all of the multiplications, there were in fact 10 of them. Okay, now we're going to do something slightly different. We're going to store successive powers of x. So we're going to take 1/2 and multiply it by 1/2. That calculates x squared for us. And then what we're going to do is we're going to store that in memory. And now when we want to calculate x cubed, we just have to take that product that we already have and do one additional multiplication by 1/2. And then we're going to store that in memory, and we can do one additional multiplication by 1/2 to get x to the 4th. And if you count the number of multiplications necessary using this method, you're going to find there are 7, and there are still 4 additions, just as before. Okay, finally, we have our third method. And our third method is called Horner's method, and here's how it works. We have the same polynomial as before, and we start off with the lowest degree term. Here it's -1, and it so happens that there's no x in it. Okay, but then we look at what's left, that's this stuff, and everything else has a power of x, so we're going to factor it out. And the first term inside will have a 5, because we have 5x here. And then we look at the remaining terms, that's these ones here, and we notice that they all still have a power of x in them. So we say plus x, and then the leading coefficient inside will be a -3. And then the remaining terms also have a power of x, and the leading coefficient is 3, and finally we're left just with this highest degree term, that's a 2x, accounting for the other x's that we've already factored out. Okay, so that gives us this result here, and if you count it, this requires many fewer operations. There's 1 multiplication, 2 multiplications, 3 multiplications, 4 multiplications, and then just as before, there are 1, 2, 3, 4 additions. Okay, so you've saved a number of operations here, and this might not seem like much to you, but if you're evaluating this polynomial many, many times, those saved multiplications are going to result in a much faster algorithm. All right, that's it for this lesson. Thanks for listening.